class, say until about 9 o'clock, and then hopefully we can finish by 9, and then after that I will let you go. Okay. All right. Okay. Yesterday we were looking at the regression analysis. Yeah, how we actually get the parameters, the beta naught and the beta 1 hat. Yeah, beta naught hat and the beta 1 hat. And then once we got the model, we say that we cannot simply use the model. We just need to be able to do some assessment to make sure that the model that we get is actually a good model. Yeah, and we actually look at two of the models assessment. All right. Yes, this is what we did yesterday. Okay, so we have looked at how we assess the model using the standard error and using the coefficient of determination. So we say that the standard error, this value will have to be small, yeah, and this value we are looking for a big value. So this is big and this is small. Okay, so today we're going to look at the other two assessment which we need to do. Yeah, number one is a t-test for the slope. So this is hypothesis test. And the other one is the ANOVA. So the ANOVA, in the last class we learned is also about hypothesis test. So these two is basically about the hypothesis testing. So we're going to do the hypothesis testing today, yeah, to see how do we assess the model. Okay. So this is what we did yesterday. All right. What we calculated. Okay, so this is what we have, yeah. So the third one, which is what we call as the testing of the slope, yeah. Okay, why do we test for the slope and not for the intercept, yeah? Because we know that for any linear equation, if our, when we have y is equal to beta naught hat, okay. Now, even if this is equal to 0, it does not matter, yeah. It's just to tell you that the line basically passes through the origin. Yeah? So the y is still dependent on the x. So for that reason, most of the time we don't do the testing for the slope. We do the testing more for the gradient, yeah, or the beta 1. Yeah. Okay. So the whole reason why we do this is to see whether is y dependent on x or not, yeah. Because if we have a value where our beta 1 is actually equals to 0, that means our line will always be equal to y is equal to beta naught. So your graph will always look like this. So if this is your x-axis, this is your y, so your line will always look like that, which is this value will be the value of your beta naught. Okay. So for that reason, even though your x changes, your y does not change. So that's why we are testing for either beta 1 is equal to 0. Yeah? So when our beta 1 is equal to 0, that means the line will take this form. So your y will not depend on your x. So that means there will be no relationship between the x and the y. Okay. Against beta 1 not equal to 0, because like I said, the slope can be either a positive slope or a negative slope. Yeah, it does not matter as long as the value is not equals to 0. Okay, so this will be our hypothesis that we have to put up. And then what is the test statistics? Okay, we are going to use the t distribution. Yeah, this testing of the slope. So what we do is we just take this test statistics, excuse me, beta 1 hat minus beta 1 over square root of sigma squared over sum of squares of the x, yeah, or sometimes called the standard error of the beta 1. I think yesterday someone was asking me, when do we use the standard error of the beta 1? Yeah, so the standard error of the beta 1 is basically used for us to calculate the t test statistics. That means what is the value of the t, And whatever the value of the t that we get, we will compare that with a value of t alpha over 2v. Yeah. So v here will be a value of n minus 2. Okay. Now again, this value, because we assume that beta 1 is equal to 0, so beta 1 hat will minus beta 1 here will be the value of 0. Yeah? So we will put in this value. Yeah. So this is basically just taking beta 1 hat divided by the standard error of the beta 1. And then whatever the value that we get, we will just compare that. Yeah. And then if it is bigger than, falls in the rejection region, so we will reject the H naught. If not, we will fail to reject the H naught. So in this case, we hope that we will reject the H naught, yeah, to say that the Y and the X can actually be put in a relationship. So how do we carry out the test? Yeah, so these are the values that you require. Okay, I just make an assumption, yeah, of alpha is equal to 0.05 because I just want to show you how we do it. Yeah, so I read this from the table. Right, this is based on that example of the electricity usage that we had yesterday. Yeah, okay, so this give us a value of 0.025. Remember, because this is a two-sided test. This is unlike the ANOVA. So this will be a two-sided test. This will be where your rejection region will be. Okay. And then we plug in the values. Okay, these are the values that we have calculated earlier. Sum of squares of the x. And then what do we have? And we put in the values. So we get a value of 6.37. Okay. So this is the calculated t. So where is the value of 6.37? Now, if this part here is 2.2228, so obviously 6.37 will be somewhere here, all right? So it falls in the rejection region. So therefore, we will reject the H naught. So rejection of the H naught means our H1, where the beta 1 is not equal to 0, is true. All right. So this is what we say. So that means to say that, yeah, whatever it is, the electricity usage will actually depend on the level of production. So we are saying that Y depends on X. So when we say that Y depends on X, so meaning to say that there is a relationship between the Y and the X. Okay, so this is what we have. So this is the third test. So a method of assessment to make inference on the slope. Yeah. Okay. Right. The last one, okay, will be the ANOVA. Okay. Now the ANOVA is like what you have done in the one-way ANOVA, yeah, except that what is different is just the test statistics, how we calculate the test statistics and the hypothesis. In the last one-way ANOVA, we were looking at the hypothesis where we are looking at the mean, yeah, whether they are equal or not, and whether one of them is not equal. But in the case of the regression, we're not looking at the mean. Our interest is always to see whether the linear relationship is possible or not. So that means always looking at the value of this hypothesis of beta 1 is equal to 0 and beta 1 is not equal to 0. Okay, we don't put the hat here, yeah, because we are not testing for the sample beta. We are testing for the population beta. That means the actual value of the beta. So we put here beta 1 is equal to 0 against beta 1 not equal to 0. Okay, so again, it's still the F ratio that we're looking at. Yeah, remember the ANOVA is a table. So what is the F ratio? The ratio will be between the mean square, the variance, yeah, between the variable in the Y with respect to the predicted Y with respect to the overall average over the observation minus the predicted, yeah, the variance index. So it's basically looking at the ratio. So it's still calculating mean square Okay, now we don't call it treatment, we call it mean square of regression divide by mean square of the error. Okay, and what is mean square? We know that last time, all right, we take the sum of the squares, divide by the value of the degree of freedom. So we divide the SSR divide by K, and the MSE is also SSE divide by N minus K plus 1. Okay. And what will be the rejection criteria? So the rejection criteria will be this. Okay, even if you don't write the not point, it's fine. Yeah. So F is equal to this ratio, and we look at a value of alpha K N minus K plus 1. Yeah? So remember this alpha, okay, we do not divide that by 2 because of the fact that the um, ANOVA is always positive. Yeah, it's a skewed distribution, so you don't have the alpha over 2. You basically have this side. Yeah, so it's always a positive value. Yeah, it's a right tail test most of the time. Okay, right. So this is what we basically have. Yeah, okay. And we summarize it in the form of the table. So the table looks like this. Okay, so you're familiar now. All right, so we have the source of variation. So we don't call it the treatment, we now call it the regression, the source of the regression, or sometimes called regressors. All right, in some books they write that as regressors. That is SSR. So put in the value of the SSR. Now, how do you determine? Perhaps the only thing that might differ is this one. So how do we determine all this value? All right, the degree of freedom for the SSR is always based on the number of independent variables. So if you have only X, so your K here will be equals to 1. Okay. If you have 2X, X1, X2, then your K will be equal to 2, and so on and so forth. Yeah. Okay. The total here is always N minus 1. All right. Remember, when we calculate the sample variance, yeah, it's always dividing by N minus 1. So for that reason, we divide here by N minus 1. So again, SSR plus SSE is equal to SST. Okay, so that means K plus N minus K plus 1 must be equal to N minus 1. Again, this is N minus K plus 1. So this is 1, then this will give you N minus 2. So that's how you get this formula. Okay, if you see this here, okay, this N minus 2 is actually the degree of freedom for the error. Okay, so basically we get it from the ANOVA. Yeah, so because your K is 1, so N minus 2 lah here. This will give you the ratio for the mean square. This will give you the ratio for the mean square error. And of course, this will be our interest. Yeah. So this is the one that we want to find. And this is the one that we compare with the table. Okay. So again, drawing of the ANOVA, construction of the ANOVA is important here because we look at the analysis of the variance. Why we look at the analysis of variance? Because we now have an X and a Y. Yeah? So for that reason, we need to look at that particular situation, and we are trying to predict the value of the Y. So there's variation in that manner. Yeah. Okay. Right. Okay. So how does it look like? Yeah. Okay. This is how the ANOVA basically look like. So yeah, so like I said to you, all right, this you already come across this in the last class. So you know how does the ANOVA look like. So we have the sum of the squares for the regression, the error, and the total. So this always add up together. These two, 1.2124 plus 0.2991 is equal to this. All right, so degree of freedom, when you add up also, this will be equal to whatever the value is, and then we get, and but our interest is always this value at the end of the day. Okay, now then we test for the significance of the regression. Okay, so this was the ANOVA, yeah, that we did for the first example, yeah, the electricity usage and that production, yeah. Okay, so since there's only one variable, so our degree of freedom is 1. This is calculated using the formula SSR. This is calculated using the formula SSE, and this is calculated using the formula SST. All right. So this is what we get. So this is how we carry out the analysis. Yeah. So always put what is your H naught. All right. Now this one I just take a level. Yeah. I assume this to be just equal to 0.05 for the lecture. Yeah. Okay. Then I need to read this from the table. Right, so remember this is ANOVA, so you don't divide that by 2. So F 0.05, 1, and 10. Okay, so we get a value of 4.96. Yeah, so that value gives us 40.53 greater than 4.96. So meaning to say that this is rejected. So what it means is that we can actually fit a linear model. Okay, so this is what we have. So this is how we basically do, or how we carry out the uh, assessment technique, okay, for the um, simple linear regression. All right. So the four methods, yeah, that we have. Yeah. Okay. So any questions? Okay. The K is here. This is the value of the K. K here is how many X you have. Okay. For example, in this case, we have just Y is equal to beta naught. All right. So there's only one X, one independent variable. So that's why the value here is 1. Let's say you have let's say you have, hold on, okay, sorry. I want to go to an empty slide. Tak apa. Okay, never mind. Okay, what do I have here is, okay, K here is, let's say my interest is pressure and the yield. The yield is Y, so this is my X. Okay, so that means there's only one independent variable that I am interested in. So here my K, it will be equal to 1. Yeah, that means here K is equal to 1. Let's say after that I say, okay, no, I want to add another variable. So let's say I now add, let's say I add here temperature. That means I now have one Y value. Okay, let's say temperature is 100, pressure is 250, the yield is, let's say, 10 kg. Yeah, so that means I now have another variable X. So now I will name this as X2. I will name this as X1. So that means now I have two variables. So my K here will be equals to 2. Okay. So this is how I decide. That means if I have 5 variables, so my K here will be equal to 5. So that means there will be the yield Y against the pressure, against the temperature, against the, let's say, volume, and then let's say against some other things that you have. Yeah. Okay. Pressure, volume, temperature, injection rate, or something like that. Yeah. Okay. So then you basically have the value of the K. Um, In the case of the simple linear regression, your k is always equal to 1, all right? Because simple linear regression means just only the y and the x. Okay, only one y and one x. So this is what we call as the simple linear regression. The next chapter, chapter 10, is on the multiple. Multiple linear regression means you have more than one x, the one that you're asking me now, all right? So more than one x. So that means, let's say we have temperature, pressure, volume, injection rate, okay? Then that gives us actually the multiple linear regression. That means we have more than one independent variable. But for now, we are focusing on the simple linear regression first. So our k here will always take up the value of 1. Okay, so this is how we do it. Okay, so any questions on the testing of the slope? Okay, on the 4 techniques. Yeah. So basically what we want is a small, okay, if we go back to this, okay, so if we go back to this, we want a small value, big value of the r squared. Now the t-test will tell you to reject the h naught. Yeah, we want this to be rejecting the h naught. And also for the ANOVA, we also want this to be rejecting the h naught. So if all this is met, all right, this is small, this is big, the t-test says that yeah, the relationship exists. ANOVA also say yes, the relationship exists. Then only we say that that model is a good model. So then only we say that y is equal to beta naught, the one that we calculated, yeah, is a good model. That means this model that we actually estimate is acceptable. If this is not acceptable, let's say when you do here something is not right, yeah, maybe you got your r squared is quite small, or even though your standard error is good, but the value of your r squared is not that good, okay, then we'll have to decide whether you want to change, you want to add more values, you want to take off some values or what, in order to improve the performance of the model. Yeah, that means improve this model that you got earlier. So you revise the model. Okay, but again, it's subject to all these 1, 2, 3, 4 tests that you basically carried out. Okay, so this is what we do. Yeah, okay. Now, like I said, okay, most of the time when we run it on the software, okay, this is how the values look like. That means doesn't matter whether it's the Excel or the Minitab or whatever, or the MATLAB. Yeah, okay, Minitab is just another software that we use. Okay, all right. So whenever we run the so-called linear regression, it will basically tell you what is it that you are actually running. Yeah, and all this information, whether what is the equation, all the 4 methods of the assessment, the values are all found here. The only thing is just that you just need to be able to actually figure out what are the important values. Yeah, okay. So the first one is, okay, this is about the electricity usage against the production. Okay, now the first one we need to do is we want to find what is the equation. Remember, we want to determine what is beta naught and what is beta 1 hat. Okay, this is our first objective. So where do we get that? Yeah, so we get it from here. Okay, this is the predictor. That means what is it that we use? Okay, constant and the production. So this is your x. If you look at it just now, this is your x, this is your constant, this is the basically what you want. So this is the coefficient. So 0.0409 is your coefficient for the constant. That means 0.409 is your beta naught hat. Okay, so this gives you 0.409. So this is the value of your beta naught. Okay, now what about your beta 1? So your beta 1 is the coefficient for the production. So what's the coefficient for the production? This gives you a value of 0.499. So this gives you 0.499, which gives you back the equation that you calculate manually earlier, yeah, where you get the value of that equation to be equals to 0.409 plus 0.499 x. Okay, so this is what we look up first. Yeah, so how to get the equation first? Okay, once we get the equation, all right, we now need to assess the model. Okay, let's have a look at how is the assessment being done. Yeah, so the first one that we look at was the standard error. Okay, where is that standard error in this table? Yeah, the standard error is actually the value of this. Okay, this is your standard error. Okay, this value is the one that you calculate here. Here, okay, the one that you calculate using this formula. Then you take the square root, yeah, SSE divided by n minus 2 using this formula, then you get a value of 0.173. Okay, so this is the standard error, which is actually shown, yeah, in the printout. Okay, all right. Okay, the next one is the r squared. So where is r squared? R squared is this value. Sometimes it gives you in terms of percentage, sometimes it gives you in terms of decimal. All right. So we get a value of 80.2, which is a value of 0. Apa tu? 0.8. Okay, which we basically get the value from here, the one that you did. Here. Okay, so this is your r squared, yeah, which is calculated from 1 minus SSE over SST, yeah, which you, if you know the ANOVA, if you do not know what's the value of the r squared, these values can all be calculated, yeah, based on the formula. So this is what we get. Okay, so that's the second test. Now the third test is the T statistics. Okay, so how do we calculate that? How do we calculate the T? Using beta 1 hat minus beta 1 over the standard error. So like I said, this value is 0. All right, so basically it's just beta 1 hat over the standard error of the of the beta 1 hat. Okay, now where do we get this in the table? Okay, this is where we get it. Okay, so if we look at this, all right, okay, so where do we get the T? All right, so you if you notice, this is the value. This is our beta 1 hat, and the standard error of the coefficient is the SE just now, yeah. So this is the value. All right, so we have standard error, so it's basically 0.499 divided by 0.07835. This is the T that we get. So this is the T statistics, the T test. Okay, and it gives you the p-value. It calculates the p-value for you because this is numerically calculated, so it can gives you whatever the p-value is. If you want to know the T statistics for the constant, it's just a value of 1.06. Yeah, so if you look at here, the value here is 0.314. So if you look at this, it means to say that the value of the t is, the value of the beta naught, okay, is basically not significant. So meaning to say that there's a possibility that in this relationship, all right, the beta naught maybe there's a possibility that the beta naught will be equal to 0. That means the line will pass through the origin. It doesn't matter because the t is basically not significant. Yeah, because you get 0.314. How do I know it's not significant? Because I will always compare that with 0.05. Yeah. So when I compare this between 0.05, so I got 0.3 greater than 0.05. So I cannot reject my H naught. So what will be my H naught here? My H naught here is, just now was beta 1. So now we have beta naught equals to 0. Okay. Against beta not equals to 0. Okay. So here tells me that this is possible because of the fact that p-value is greater than 0.05. So we fail to reject this. So what I'm saying is that there's a possibility that the line will just pass through the origin. Okay, it does not matter, or the constant there does not actually play a very significant role, yeah, in the whole of the equation. But the x is, yes, is dependent, the y is, yes, depending on the x, because the x here, all right, the p-value here is 0. Yeah, so this is how we analyze this part. Okay. So we have the equation, we have method number 1, we have method number 2, we have method number 3, and obviously this is the last one, which is the ANOVA, which is method number 4. All right, sometimes the value is given to you, the p-value is given to you, and sometimes the p-value is not given to you, so we just need to look at the table. Yeah, so all this we have gone through. So we have basically calculated that. Now, how do we get S from here? This is actually the square root. Square root of 0.0299 will give you the value. Because we use the formula SSE divided by n minus 2. Alright. So since we use SSE divided by n minus 2, okay, so basically it's just having this. Yeah. So we have that. So this is just the square root of this, yeah, because this is our variance, estimated variance squared, yeah, and the square root will give you the standard error. So this is how we actually interpret and regression analysis table. At the end of the day, all right, what we just want to say is that the model that we get is a good model. Not say it's a good model, meaning to say that that model is acceptable, all right, based on that data set that you have. So we can use that model to basically make some prediction or whatever that we would like to do with the model. Okay, any questions on that? Any questions? N based on X or Y? No. N is overall number of observation. That means how many data set you collect. So if you have 20 observations, then you will have your N is equal to 20. That means if your sample size 2 is 10, then your N is equal to 10. That's the meaning of the N. N is the number of observations. Okay, let's look at this example. Yeah, all right. find the least square regression line. Okay, and then let's say I want to put here, I want to add here, carry out. Can carry out. I'm just going to put here test. Okay. Yes, the SE beta here, yes, refers to the standard error of, uh, no, it refers to slide number 14. Okay. Here, it refers to the standard error, not the one that we calculate, but standard error of the coefficient. It refers to this. Here, it's a standard error of the slope. What we calculated, the standard error of the estimate is the overall standard error. Okay, so the SE beta 1 means is the standard error of the slope. Okay, yeah. Okay, right. So let's look at uh, that question. Yeah. Okay, so basically I want to find a least square regression line on income, yeah, in 100, and food expenditure also in 100 on the 7 household given in the table below. So this is my data. Okay, and after that, it says here test for the significance of the regression. That means I'm supposed to analyze, okay, and carry out the whole test. Okay, so 7 household, that means I have 7 set of data. 1, 2, 3, 4, 5, 6, 7. 7 for X, 7 for Y. So that means here my N is equal to 7. This is how I get the value of my N. Okay, so how I'm going to get the value for the least square regression line. That means I want to find what is beta naught plus beta 1x. Okay, so this is what I want to find first. What are these two values? Okay, then only I will get the equation. Okay. Okay, so what I do is I just need to calculate first, because I'm going to use a formula, the sum of squares of the x, sum of squares of the y, that formula that I have, that long formula. So I need to do what is necessary first, yeah. So I need to find xy. This is manually done, all right. So I need to find the value of the x squared because I need to use all these values to get my beta naught and my beta 1. Okay, right. So this is what I do first. Okay, because for my beta 1 hat, I need to find the sum of squares for the xy over the sum of squares for the x. Okay, so I have to do it manually lah. So I calculate manually. All right, what do I get? And I calculate. In the end, I get my sum of squares for the x is this value, and my sum of squares for the y is this value. So in order to get my beta 1 hat, I get a value of 0.2525. Okay, and I plug in the value to get my beta naught, right? So my beta naught gives me 1.5050. So my equation line will be a value of this. Okay, so that means to say that my household income is equal to 1.5050 plus 0.2525x. So here is income. Okay. Here is my expenditure, food expenditure. Okay, so I got this equation. All right. So what do I do next? Normally this is what I do lah kalau I buat ya. Alright. So what I do next is I always try to see what does it means physically, and what does it means that, hold on, I need to charge my battery. My laptop. Okay. So what does it mean Alright. So what it means is that what is the interpretation of the beta naught and what is the interpretation of the beta 1? Okay, that I got. So for the beta naught is just a constant, so meaning to say that I'm more interested in the value when my x is equal to 0 lah. So it means that when my x is equal to 0, then I would expect that the household income, when I put in the value, this is not this is just my expectation, whether the model is right or not. I will have to test it first, but this is generally the interpretation of the equation that I get. Okay, so when my household has that means no income for the household, the expected expenditure is 150.5. How do I get 150? Because it's in the form of hundreds, the value, the table. So that gives me 150.5. Okay, so this is what it means. Okay, now when I want to look at interpretation of beta 1, so I just want to see, okay, that means when my x increase, I just take a value, does it matter 50, 51, 45, 60, whatever, I just take 50 and 51. So when my x increase from 50 to 51, that means my y here will increase 0.2525, which is the slope that I get, which is actually the value of my beta 1. Okay, right. So what it means is that, let's say increase by 1 means increase by 100 ringgit, or $100 or whatever. So I will expect that the the food expenditure will increase by a value of 25.25 ringgit, for example. Okay, so this is my interpretation of the beta naught. Okay, just to see whether what I get is reasonable or not. Meaning to say that sometimes, for example, I may get an equation and suddenly is a yield, and I get my my beta naught to be equals to 0 or negative value. So I just need to see whether does it make sense or not, the equation that I have. Okay, all right. So once I got this, I'm okay with that. I now want to assess the model. So the first one I'm going to do is I'm going to calculate the standard error. After that, I'm going to do the R squared. I'm going to do the t-test. And finally, I'm going to do the ANOVA. Okay, so I do the error first. So error, again, very mechanical. I just need to know my standard error is given by SSE n minus k plus 1. All right. So these are all just mechanical. I just need to put in the values. Okay, what is SSE? SSE is given by that formula. So I just need to calculate what's relevant. And then in the end, I divide that. So I get a value of 1.5939. So this is my standard error. To say whether it's big or small, okay, I would think that it's quite small, but nevertheless, I just need to see that the rest of the assessment actually goes well. Okay. So this is the first technique. Okay. Then now I'm going to calculate the R squared. So I do the calculation for the R squared. So R squared, I just need to know what is SSE, what is SST. I'm going to use that formula. So I calculate my SST again from the formula that I have. I've calculated the SSE earlier. All right. Oh, this one, there's no sign. All right. And I get a value of 0.9. So that means this is good, because this is 0.9. So meaning to say that 90% of the food expenditure is accountable or contributed by the value of the income. So this is a good one. All right, because my here is actually 90% or 0.9. Okay. Okay, so I got quite small, 1.5, reasonably enough. All right. Now I got 0.9. So I'm going to do the third one, which is the t-test. So I do the t-test. All right. So again, this will be my hypothesis. All right. Okay. These are all again mechanical. I just need to read the value from the from the table. Yeah, I take alpha is at 10%. Yeah, I just pick 10%. Yeah. All right. Okay. I have it here 2.015, the table, and then I get a value of 6.662. Okay, if I do not want to use this, I can also use the p-value technique. Yeah. All right, so I'm going to get this a value of 6.662. All right, so sorry, so 662. Okay, I copy paste from the other one. Okay, 6.662 greater than 2.5405. Mana ni? Okay, 6.662. This value bigger than this value. Yeah, then I will reject this. So this is not true. So this is okay. That means my income can be a negative gradient or positive gradient. Does not matter. All right. But looking at I got it as a positive, yeah, in here. All right. So that means it should be a positive. So I see that the food expenditure depends on the household income. So this is my conclusion. Yeah, that the food expenditure, the Y, is actually depending on the household income. So not enough. I need to carry out the ANOVA. So I'll do the ANOVA. All right. So this is my ANOVA. Okay. I carry out the ANOVA at 5%. Yeah. Okay. Rather than 10%. It's just a choice. Okay. So I put it as this value. This would be my beta 1 and my H1 and my H 0. So I calculate, I pick up back the values that I have. All right. Now this here is 1 because I only have one variable, which is the income. This I have 6 because altogether I have 7 variables. So 7 minus 1 will give me 6. So my error will give me n minus k plus 1. Yeah? So 7 minus uh, 1 plus 1. So that gives me 2. So that will give me 7 minus 2. That will give me 5. So at the end of the day, this is my interest. So I have a value of 44.4102. Then I look at the table. All right, this is U. I need the U. I need the V. Yeah? So the U is this one. V is from here. So I get a value of 6.61. So of course, this is much bigger. Then I will reject the H 0. Okay. So what it tells me is yes, I can fit a linear model between the food expenditure and the household income. Yeah. So the ANOVA tells me whether I can fit a linear model or not. The t-test actually tells me is Y really dependent on X? Yeah. Okay. So this is what I do. So at the end of the day, I know that okay, all these 4 tests leads to telling me that the model is a good model. So now I can use that if I want to make whatever prediction that I would basically like to do. Okay. So supposedly I'm quite clear of the model. I now want to predict. Okay. Let's say I want to find the expected food expenditure. Yeah. If the income of the household is 45. So what I need to do is I just need to plug here. That means this is my beta naught, my beta 1. This is my X. Yeah. So this is my X. So I just put inside here. So I get a value of 12.8675. Okay. Now when my X is equal to 90, yeah, if I plug inside this value, okay, I am going to get a value of 24.23. Okay, but I cannot use this. This is not right. I cannot use this model to predict when my x is equal to 90. So this model is only valid for 45, but not when my x is equal to 90. Okay, why is it that I cannot use this model to predict for the 90? Because if I look at this, all right, if I look at my data set, okay, my income is only from 33 up to 83. Yeah, that's the maximum is 83. So 90 is already out of this range. All right, so 90 is too far away from 83. So because 90 is already out of this range, I cannot use this model to predict, because this is the model that I developed is just based on this data set. Yeah, so you only be good for data that ranges between the minimum and the maximum value lah of whatever the x is. So in this case, 90 is not there, so I wouldn't risk of using this model to estimate what is 90, or if beyond that. Yeah, okay, the closest I would do probably is about 84, 85. I'm quite comfortable to use the model. Yeah, but beyond that, I think I will not use the model because it's too far away, and this model is just estimated based on the data. Okay, so I think that's it. Yeah, that's it. Okay, so that's done for chapter 8. Okay, any questions? No, you don't. Basically, if you use the Excel, you don't need to use the manual calculation. All right, I will show you how to do the Excel. No, we don't do. I did, because Excel gives you the whole lot, so I don't think so. You need to do the manual calculation. Okay. All right. So I'll show you how we do the Excel. Hold on. Let me open up the. Okay. So let me show you how we do the Excel. Okay. So I hope you can see the Excel. All right. So what I do is, first, in order to use the Excel, you need to have whatever is the data for your data lah. All right. Whether which is your X and which is your Y. Okay. So once you got the data fixed, which is your Y, which is your X, so income is your X, food expenditure is basically your Y. So what we do is we run the data analysis. Okay, pick the regression. Okay, for the ANOVA, yeah, the last class, you pick this ANOVA single factor, yeah, if you want to do the regression for the last class. All right. So here we pick the regression. Okay. All right. Now, what is your Y range? Okay, so input your Y range. So your Y range, Y is food expenditure. Okay. Your X range is your income. All right. Put the labels. Okay. So so this is set automatically. This is set at 95% if you want, or you can change if you want. So we just keep it at 95%, and then we do the output range. Okay. Let's say This is the range. Okay. Then the rest is just the plot. Whether you want to have the residual plot, normal probability plot and whatnot. You may not use this unless necessary. Then we run. So this is what we get. So the Excel calculation is a bit different. My calculation is a bit different, because I use a manual calculation. All right. Okay. Let me explain to you what we have. Okay. All right. So this is what we have. Yeah. All right. Just like the output just now, we are interested in getting the equation. We are interested in getting the values, all those four values. Okay. So let's look at the coefficients first. All right. So you notice that this is the intercept. So this will be your beta naught. So which is a value of 1.5073. Okay. This will be the value for the beta naught. Okay. And our X just now was income. All right. So what is the value of the beta 1 hat? So beta 1 hat was 0.25245. Yeah. So this is the equation. So this is what we have, yeah, for the values. Okay. So this gives us the beta naught hat and the beta 1 hat. Okay. So the next one is the standard error. Okay. So where is the standard error? All right. So standard error is here. Right. So this is our first test. Okay. So this gives you a value of 1.9508. Okay. The next one is the R squared. All right. So R squared, we take this R squared. Yeah. The adjusted R squared means there's some normalization being done here. All right. That's fine. All right. So we look at the R squared, which is 0.898806. Yeah. And this is our observation. That means there are altogether 7 values that we actually key in, which is correct lah, if you base it from here. All right. So this is our standard error. This is our R squared. Yeah. This is the coefficient. Okay. So what's the T statistics? The third one, we look at for the income. All right. This is what I calculated just now also. 6.66. So it's calculated here. Yeah. So that gives me this value. Okay. And the beauty of the answer is that it gives you the p value. Yeah. So you know that this is significant from the fact that 0.001. All right. So this is significant. Now, the extra thing that the Excel have is that it calculates for you the confidence interval for your beta 1 and your beta naught, right? So, which this is also another test that we normally do, um, but most of the time we just rely on these four. So the CI is basically calculated for you, the lower CI and the upper CI. So this is also another test that we also run. All right, this is an extra test that could be considered to see whether the beta 1 is actually equals to 0 or not. Yeah. So if because you notice that beta 1 equals to 0 does not lie in this interval. So for that reason, we will to reject the H naught. But in the intercept, all right, because the p value is 0.15, okay, if you look at it, it will not be significant and it's reflected in the CI because this is -4 and going to 7, you will cross the 0. Yeah. So when you cross the 0 here, all right, so that means to say that it is not significant lah. So for that reason, kita kata dia tak significant. All right. So but our interest is not so much on the intercept. Our interest is more on the beta 1, the slope. Okay, so that's test number 3, and the last one is of course the ANOVA lah, which is test number 4. Okay, so again, the ANOVA, the beauty of this, it gives you the significance, so you know that this is about 0. Yeah, so for that reason, we know that, okay, this model of y equals to this value is basically an acceptable value lah. So that means to say that this model is basically accepted. So this is how we do it when we run on the Excel. Okay. All right. So this is whether it is a multiple, it is single, it can be done in this manner. Yeah. All right. So basically, it's quite good for you to know this, so that whenever the next time when you do any analysis or whatever, this will help you to determine or build the relationship between the X and the Y, provided it is a linear relationship. Okay. Right. So any questions? Interpolation of beta 1. What do you mean by interpolation? I don't understand. Our test, yeah, I would say so. Yeah, because the Excel is for you to, yeah, I would say so. Like I said, my interest is more of how you do the interpretation of the what do you call the interpretation of the questions. No, question interpretation of the results. That would be my interest. Hold on, yeah. Excel calculate everything. Yes, Excel calculate everything for you. Yeah, basically when you do the Excel, hold on, Wong, I'll get back to you for that page 25. Okay, basically when we calculate the Excel, yes, it will give you the whole 4 assessment. Later during the test, we will just show the screenshot. Mm, what do you mean by you just show the screenshot? You just if we ask you the question on let's say on the regression analysis, you just copy paste je lah okay, yeah, I see what you mean. Yes. Okay, yeah. Just show the screenshot. Okay. Do we need to use Excel for our test? It's your choice. It's your choice. It's your choice. Basically, it's your choice. If I give you a data set of size, your n observation is actually 50. I don't think so you'll be able to calculate manually. All right. So I would like you to use the Excel. Honestly, I would like you to use the Excel. Yeah. But if your data set is only a 5, 2, then you can do it manual calculation lah. But if your data set is like, if you want to use the Excel, at least choose a big your n should at least be big. Let's put it that if you want to use your Excel, let's say that when we have our n is at least about 30 or something like that, then that would be something that I wouldn't expect you to do it manually lah. Kalau 7, 5, 7, I think we can still use it manually. That's what I did manually just now. Okay, wait, hold on. Let me clear this one, page 25 first before I answer your question, Adam. All right, okay. What is page 25? Oh, okay. Interpolation of beta 1 again. Oh, okay. What I meant here is what does the value of the beta 1 means? Okay, so what it means is just that if I increase from 50 to 51, that means I increase by 1, yeah. All right. My y hat will change from 14.1300 to 14.3825. Okay, so this is what it means. And if I take away, this increase is 0.2525, which is basically, if I go back to the equation, this equation, this is a value, right? 0.2525. So what is the meaning? The meaning is that if I change from, that means if I increase from 50 to 51, increase by 1 here means increase by 100 ringgit. Yeah, all right. So on average, if I increase by 100 ringgit, I will expect that my food expenditure will increase by 25.25 ringgit. That's the meaning of this interpretation. I just want to Okay, the reason why I do this, and normally I do this is because sometimes you have sometimes you get a model, but that model when you try to put that in the physical situation, it doesn't make sense. For example, let's say if I say I get y hat is equal to negative 1.50 plus 0.2525. So meaning to say that when my value is zero, I will have a negative expenditure, which to me doesn't make sense. You get me? When there's no income, you are expected to, oh, okay, that means you have like negative. So to me, it doesn't make sense. All right. So sometimes when you get the equation, you need to figure out first, before you think, okay, does this equation, is it okay or not? Yeah, sometimes you think it's okay, but sometimes it's not. Okay, so that's why I always try to do first. Okay, to just have a little bit of understanding of what is the physical relationship that trying to do. Okay, for the quiz later, can we go back and forth? I think so. Yes, should be no problem. How many quiz for this course? Yeah, two. This is your last quiz. Okay. Or any other questions? Yeah. So you have 25 minutes to do the quiz. All right. So there'll be some calculations involved. There'll be some theory involved too. Okay. So make sure you have your tables, you have your calculator. 10 question. How do you know 10 question, Adam? I don't know. Okay. Yeah, Adam, it's 10 questions, I think. I think you must have heard it from the other groups. Okay. Yeah, it's 10 questions. Okay. Yeah. No, no, no. Quiz one, there's 15. There's 15 questions. Yeah. This one, I think it's 10 questions. So 10, yeah. I'm not mistaken, there's 10. Yeah. Okay. So 25 minutes. Uh, like I said lah, work out and do it. Okay. So make sure that you have your tables, whatever that is actually required. Year, yes. In the exam year, you just need to show the Excel thing, okay? Yeah, okay, yes, but yes, but do it properly lah. Maksud saya, when you do the conclusion pun, you read properly lah. If it's a hypothesis test, you have to have the hypothesis like that. You must have the H naught, H1, and so on and so forth. Yeah, with a proper working, yeah, you can use the Excel, okay, output, okay, but with proper working lah, maksud saya, proper interpretation and proper working, that is most important. Okay, all right, any other questions? I think you're okay. All right, so we are done with this chapter, so we only have one more chapter to go. Okay, yeah. So okay, all the best for the quiz. It's already 9:15. I want to stop by 9:15, 9:12. Okay. So yeah, it's an MCQ, all right. So if you don't know, just guess whatever you think the value is. Okay. All right, yeah. Okay, so have a good weekend. All right, to those yang nak celebrate raya, selamat raya. Okay, all right. Going home or no, you're at home kan? All right. Okay, so have a good break, have a good weekend. All right, so I will see you all next week. Okay, all right. Okay, thank you. Okay, all the best yeah for the quiz. Okay, take time to answer the quiz, but not too long a time lah. Kalau takut nanti you lambat calculation ke whatever. All right, but you can go back and forth. Don't worry. Any problems with the quiz? You tak boleh internet you out ke whatever? Just let me know. Yeah. Okay. All right. Okay. Assalamualaikum. Okay. All the best.